What's going on, guys? My name is Kui. You may know me on Discord and Telegram as Moto Engineer. And today, what I have here is a printed out copy of the Mono white paper. And I kind of went through it, I read it, tried to get a better understanding of it. And what I'm trying to do today is going to be reading along some key points in the Mono white paper. I'm not going to read everything. There are parts of it that are more geared towards understanding how gas works in Ethereum, which does have a lot to play in how someone would understand Mana. But if you decide to read the entire white paper about Mana, you get a better understanding of gas as well and why Mana came to be. But I will be reading some key parts of it, giving you my thoughts on it, and hopefully you'll get a better understanding what Mana is. And any questions that we have or any areas where I get hung up on, we'll try to ask Koinos Group themselves and see if they can give us the answer to it. Okay, so the Mana white paper. The first part here that you have to read is the introduction. And in here it says that the purpose of the Mana system is to allow liquid token holders to perform feeless transactions in an economically sustainable manner while minimizing cognitive load, right? So the tokens are Mana is only available to token holders who have liquid tokens, because we know that this coin token can be staked. If you don't stake your tokens, you have liquid coin tokens. And those liquid coin tokens are the only tokens that get Mana. You don't need to understand how Mana works in order to use it. And we'll get deeper into that later. Cognitive load is a big important thing, because in order to get mass adoptions, people need to be able to use things super, super simple, to the point where they don't even need to know how Mana works in order to be able to use it. The other thing he writes here is that it is a dynamic system for incentivizing consistent network usage while mitigating spam, thereby minimizing long-term state growth. So what he's saying there is that Mana, like gas, prevents people from spamming the network. And if you can't spam the network, then you can't add to the state. So state growth here means the size of the blockchain. The smaller the blockchain can be, right, the less resources it needs to maintain itself. There's another sentence here that says, Mana also provides a system with an objective method for determining whether and to what extent an account can be deemed a user, which can be useful in decentralized governance. So that's a very broad statement here, and I've been trying to figure out how what this really means. I think that there is some connection between Mana and being able to identify what or who is a user, right? But I think there's some connection with how Mana is being used, or who has Mana, and whether or not that person is a bot or an actual user. So the next part here is the mental model. This is a very good part right here. In order to mimic this user experience and deliver a frictionless blockchain user experience, we conceive every coin as being born with a certain amount of Mana, which can be consumed when the user consumes resources. So that means every single coin inherently has Mana. All this really means is that you can't take it away from a coin, because it's a property of the coin. It's built together. So if you have coin, you naturally have Mana. There's nothing else you need to do, right? In other words, the user implicitly possesses Mana by simply holding liquid coin, but this Mana only materializes after the transaction takes place. So there's no hold on the state. It's not as though you have, say, you've got 1% of the token supply, and therefore you always own 1% of the network resources, whether or not you consume it, and 99% is consumed by everyone else. So if you're not actively using it at the time, that means that you don't reserve any particular part of the blockchain. And that's what it means by it only materializes after the transaction takes place, without the introduction of any additional systems or complexity. This design creates an ever-increasing opportunity cost with performing feeless transactions, because choosing to keep one's token liquid inherently precludes them from participating in any yield-generating activities, such as block production, staking, yield farming, DeFi. So those are some of the items that that we talked about early on in the introduction, when we talked about liquid token holders, right? If they're not staking, which is one thing that you can do with your coin token that prevents you from accessing your Mana, including block production, staking, yield farming, DeFi. So if you're participating in those activities where your actual coin token is being held for something, then that means that you won't be able to get Mana. As the platform grows, right, it acquires a larger number of variety of dApps and users. The opportunity costs associated with performing feeless transactions will naturally increase. So what that means is that as you get more and more dApps on this blockchain, on the coin blockchain, you have to be selective on how you use your Mana. Because if you burn all your Mana on really poor developed smart contracts, or for things that don't benefit you in any way, then you end up not being able to do things that do benefit you, that have better applications, right? So that's the opportunity cost. So that means what happens is that when you start running these applications, you're going to think, should I really burn mana to run this application, or should I use it on a different application because that's a better one? And that naturally allows users to determine how they could consume mana. Token locking and regen. All right, so once any of the mana in a given token is consumed, the blockchain should interpret the entire token as being locked or non-transferable for a fixed period of time that would be specified within the mana smart contract. So the mana smart contract is a smart contract built on Koinos with system level privileges, right? It is not the same as a user deployed smart contract. This mana smart contract has special privileges and is part of the base level framework for the Koinos blockchain. And what it says here is that when you burn mana, you end up locking it. So in this example they have here, which I won't go into, but in their example, they basically say that when you have mana and you consume a little bit of it, say you consume 5% of the mana on your token, you can't transfer that token. Because if you transfer that token, then someone else has it, and then someone else will end up using the mana. And I think they require you to reach 100% mana before you even transfer it over. And that's another way I think they use to prevent spam. The regen time should be Satoshi based. So this is another important detail here, meaning that it is based on how long it takes for one Satoshi of mana to regenerate, with regeneration happening on all tokens at the same time. So despite being a fixed period, the mechanism is distributive and the regen time appears dynamic to the users. So what this means is that you have one coin and it has one mana, right? And you can burn a Satoshi's bit of mana, which is I think like 0.00001 bit of mana. And if you consume, say, like 10% of that mana, you have access to 90% of it. That 10% is recharging at a linear rate, but you can still use the other 90%. And based on when you use it, everything gets recharged at a linear rate. So if you use it more often, then it may appear to be dynamically recharging, but in reality, every bit of mana that you use is recharging linearly, and the summation of that may appear to be dynamic, but it is not. The other cool thing here is that it says a fixed lockup period is computationally efficient and delivers a more predictable user experience, while still appearing to be dynamic to the end user. But what if the wrong period is chosen? So the mana smart contract is a smart contract with system level privileges. And with system level privileges, you can upgrade the smart contract in band. That's one of the features of Koinos. So if you choose the wrong period, you have an upgradable smart contract. All you need is have governance of that smart contract, make the changes without disrupting the network performance or creating additional operational overhead for node operators. A node operator is going to just get the updated smart contract and execute it. You won't have to do a hard fork. Transaction ordering and failing. So one unique thing here is that transactions are processed based on the order in which they are submitted. In other words, called first in, first out. If the transaction requires more mana than the max mana that you specified, then this transaction should be cut off at the max mana and a transaction reversion should occur. Now, I believe this is distinctly different from Ethereum, where you don't have a first in, first out situation. In Ethereum, you have to pay, you can actually pay more to get your transaction processed so you can jump the line. If you got more money, you can jump the line. That doesn't happen in Koinos. It comes as a first in, first out, no matter how much mana you're trying to consume. The next part is going to be separate resource pools. This is a part of the mana white paper that I think we haven't really discussed too much in the Telegram and Discord chats. So it's a very interesting part. I'd like to give you more information about it, so I'm going to read you what I think it means, and this may be one of those things where we should do a kind of Q&A with the Koinos group and get some answers for. So in this separate resource pool part, it says resources should be pooled every block. And it also says Ethereum's gas calculations are one-dimensional, pricing very different resources such as storage and compute as if they're the same. So by working through this, it seems as though, and it does make sense, right? In Ethereum, if you want to upload a smart contract, you're taking up state, all right? You need storage on the blockchain. The blockchain will grow bigger in size by storing that smart contract. But running a smart contract or executing a smart contract, computing may take up less resources, right? It doesn't take up state. But in both cases, the gas fee is treated as the same. Now, it says here in the preceding paragraph, resources should be pooled every block. And it seems as though each block may have a mana pool for storage and another mana pool for compute. Because at any given time, maybe someone is uploading more smart contracts than they are executing it, depending on what time of day, whether the developer is deploying at a certain non-usage time. But what that says is that the resources can be separated. The chain can actually understand different resources and compute the cost to execute them, whether it's storage or compute in this example, separately. And that actually leads to the far more, and actually says it right here, Mana solves this problem, leading to a network that makes far more efficient use of resources. With the Mana resource model, the resources are tracked separately, but the user is still only charged in Mana. So I'm going to skip that one and go straight into, real quick, the dynamic versus active staking part. What I've highlighted here is that the system automatically stakes the minimum necessary and then returns liquidity as quickly as possible. When you run a feeless transaction, you have to provide some mana to be consumed, but we don't know how much mana is necessary to run or execute that smart contract that you're running. So it stakes the minimum necessary to get that contract ran, and whatever it doesn't use, it returns back to you. So this is a much big improvement from previous blockchains such as Steem and EOS, where you actually had to actively stake your tokens before you had the ability to transact. So on Steem, for example, you could not perform a transaction unless you had Steem power. The way you get Steem power is by staking Steem, right? And so as a user, you actually have to figure out, well, how much resource do I need? So that determines how much Steem power I get. And Steem power, when staked, gives you access to the resource the resource credit system, which is the predecessor to Mana, and also it gives you ability to generate yield through passive yielding in Steem. Both things occur through the same action, right? And a user can't know how much they will ultimately need in terms of resources, or in this case Mana, so they will naturally stake well in excess of how much they think they will actually need. Right? And that goes back to locking the token. You burn mana, you consume mana when you need it, and the system automatically takes what it needs and returns back to you what it doesn't need. Furthermore, once the user has staked tokens, it requires a conscious action to unstake them. The friction on both sides is working against the user. So again, looking on Steem, in order to get access to the resource credit system, you had to stake you had to power up your Steem. That locked your Steem for a period of time. And on top of that, you had to unpower your Steem, and that took, I think, last iteration took 5 or 13 weeks. So next part is now the XYK, which is how Mana pricing occurs, right? So Mana pricing algorithm is an in-band upgradable smart contract. Again, it's another system level smart contract that can't be upgraded without a hard fork. Governance should be able to change the way how it works. However, they clearly write that this is extremely unlikely because XYK algorithm is the ideal solution to this type of problem. It's like the traffic light. It was invented a long time ago. We still use it, right? It's a really, really good solution to the problem. But certainly it can be upgraded if necessary. So there are a certain amount of system resources contained within a block, right? And this can be accurately conceptualized as a supply of resources that increase linearly over time as new blocks are created. So what is XYK? I'm not going to get too deeply into what XYK is, but here they give you a nice, good example or explanation of what XYK is. So on the supply side, you get X, right? On the demand side, you have Y. The supply side is how much resources the network has, whether it's just how many computers are actually operating and able to contain the blockchain and also execute the blockchain, smart contracts on the blockchain. The demand side is the human actors, right? The people who want to execute smart contracts. And that XY is equal to K, which is a target, targeting a constant amount of resources K over time while ensuring that if demand outpaces supply, the price should approach infinity. So XY equals K. If there is not enough resources to supply, if there's not X and Y resources to meet K, you're going to reach a system where the cost of mana reaches infinity, I believe, right? There's also the opposite occurs. Conversely, if there's underconsumption of the network, below average demand, the supply will max out, making the price very, very low and allowing it to stay very low. So that means that with constant k, x and y has to reduce, x or y has to reduce. Either the number of people are going to use less of it, or the number of computers connected to the node that run the chain are going to reduce. Individual resource markets. So I've only highlighted a couple items in this one. Koinos has a market for each individual resource, right? So because the XYK market maker is its own system level smart contract, it can be used, composability, right? It can be used by different parts of the blockchain. So the Mana system can use the XYK market maker built in to charge more mana as it consumes more resources and less mana for under-consuming resources. The XYK market maker, although this is a Mana white paper, the XYK market maker could probably be used for a whole host of other things because Koinos is highly composable. Everything is made out of a smart contract. And I also highlighted here that the London hard fork bolsters this argument because it demonstrates the value in automating the process of resource management. Automated resource management system is highly desirable because even Ethereum did it, right? There's another section that says receiver pays mana, which really goes into implicit and explicit delegations, which actually has its own little section. But basically, receiver pays mana means that anybody running a decentralized application who doesn't have any coin, they can still run the smart contract, which is insane. Right now, you have to have a wallet with tokens to even run a smart contract. But if you are running a smart contract on Koinos, you potentially don't even need to have any mana. You potentially don't even need to know what mana is or have any coin because you can execute the smart contract and the person who developed the smart contract can point to who pays the mana. Someone else can actually pay it for you and you can still experience the smart contract. Another section here that I highlighted in the receiver pays mana is also, it says that the delegation that someone does, that gives you, right, could potentially only be used within the developer's app. So that means that if I'm a developer with Coin, I want you to use my application, my decentralized application, I can basically say that you can run my application and I will pay the mana, but only my mana can be used to pay for my application. You can't use my mana to pay for another application. So the developer can also do something where they can place limits. So they say, well, you can only get 10 mana, right? Which limits how much usage you have out of the application. If you want more, you can go buy coin yourself, right? Interoperability. This is getting to the last part of it, right? So the interoperability part is kind of a the creme de la creme of why this exists, I think. And I'll read you one little bit here, or maybe two bits. The primary source that prevents interoperability from occurring is obvious. It's fees. So imagine being able to move seamlessly between Bitcoin, Ethereum, Koinos, and any other software solution while maintaining a smooth and pleasurable user experience because you aren't forced to pay fees the moment you want to do anything useful. That is real interoperability, and Mana is a central system to realizing that vision. I think this part almost is the reason why anybody would basically ape into this token, right? You've all felt it. In order to get from one chain to another, you got to pay fees usually both ways. If you bridge to, say, Cardano or DOT, you pay from Ethereum. You pay the Ethereum fee to go one way, and when you go back, you got to pay another fee because on both sides there's a smart contract running. They're both fee-based systems. There's this fees occurring on both ends. You're just getting hammed with fees left and right. And people are saying like, well, let's reduce these fees to like low. Let's do better. Let's just eliminate the fees entirely, make it zero, and that's truly going to give you interoperability. I know people who are now running bridges and they're paying fees and they're just thinking about, oh, okay, well, is it better if I do it now? Should I do it later? What's the bridge cost? What's my opportunity cost? Because I'm losing some of these tokens that I can't bring back over to this, to its native chain or to another chain. And that just makes it so freaking hard to use. Right. And if we eliminate fees, you can go seamlessly whenever you want, when you need to. And that, I think, is the reason why anybody looking at the blockchain will immediately just ape into it. Lastly, scaling. So I got a couple items highlighted here, but I won't dig too much into scaling because the stuff that I'm going to read is kind of obvious by itself. The solutions for scaling work on feeless or fee-based blockchains. Because scaling doesn't really have to do with gas fees. So whether or not the best scaling solution out there is sharding or rollups, it can be deployed on Koinos as well. And having Mana along with that scaling solution is a very powerful thing. So he says, fee-based blockchains are inherently less scalable because they must sacrifice long-term costs for short-term user experience, which is what Ethereum did in the London hard fork. And so this forces them to find a solution to scale sooner than Mono. This whole issue with scaling is, I think, its own deep dive topic, so maybe I'll do another video on that one. But the last thing I highlighted here is basically how I'm going to end this video. For these reasons, we believe that Mana is more than just a fee-less solution to the halting problem. It is a key to achieving the mass adoption of blockchain technology through integration into a free-to-use, internet-based application that the public has been accustomed to using. Fee's great. Free is the best thing in the world since sliced bread. We love using free applications, and we learn to use free applications. A lot of those big applications, social media applications, are all free, and because you're used to using them that way, they should remain that way because that's how people tend to adopt things very quickly. So that's the Mono white paper video. If you have any questions, please feel free to message me, tag me in the Telegram Discord group. Ask me your question. If I can't answer it, we'll create that into an AMA and we'll ask the team and get some answers from them. All right, great. Thank you guys. Take care.